Good day everybody, Jonathan here and Li Zhi here. Today we'll be doing Lab E3 report, and right now we'll be doing part 1 for this lab report, which is Charlieplexing LED. So for this part, we'll set the input port C, which is pin 5, pin 6 and pin 7. For the output is we set it to port A, which is using pin 2, pin 12 and pin 13. And we have constructed the circuit according to the diagram, and now I'll be giving a brief explanation on the coding. So as you can see, this part, void initialize Charlieplexing, will be enabling clock to port A and port C, and after that set port C, pin 5, 6, 7 as input ports, push pull enable, pull selection and active low port. And also we need to set the port for the current direction. Set port direction as input. And after the initializing of Charlieplexing, we need to set the LED so that the LED will light it up according to the LED number. So for example, if we want to get the first LED to light up, we need to set port A pin 12 as input, pin 2 and 13 as output with high drive strength, and also the port direction needed to be set. As you can see, pin 12 is set as input and pin 2 and 13 as output. And for LED 1 to light up, the direction for output 1 is set at port A pin 2 as high, whereas for port A pin 13 is set as low. Right now I will be using this diagram as an explanation to how to light up the first LED. So to light up first LED, this pin 12 is set as input, whereas with high impedance, and then the pin 2 will set as output as high, so that the current will flow in the first LED to light it up, and the pin 13 will set it as low output. So from the circuit board, as you can see that the first LED will light up consistently to the end of the 6th LED. Okay, from the circuit board just now, we can see that the LED 1 is aligned up to LED 6. So for this to function, we added for loop with a suitable delay so that the LED will light up consistently with a delay set. Okay, for the switching part for part 1, Charlieplex LEDs, we have to include the read input function, which the variable value will be GPIOC PDIOR and with the input, and to read the value at port C, pin 5, 6 and 7. So after reading after the variable value is stored, it will shift 5 times to make the value readable. And after that, from the integer main, from the main function, the read the I will store the read input from port C pin 567 and set the LED accordingly and light up the LED. So for the first LED to light up, we switch it to 0, 0, 1, which you can see that the first LED light up. And for the second LED to light up, we switch it to
0, 1, 0.
0, 0, 1, 0.
The second.
And for the third LED to light up,
0, 1, 1.
we set it to 0, 1, 1.
And then 1, 0, 0.
For the fourth LED to light up, we set it to 1, 0, 0. And for the fifth LED to light up,
1, 0, 1.
we set it to 1, 0, 1.
倒反倒反
Yeah, 1, 0, 1. And for the last LED to light up, we set it
1,
to
1, 0.
1, 1, 0.
倒反倒反 1, 1, 0. 下，第一个跟第二个下。
110, yeah. And
等一下，继续。
And that's all for part 1.
Okay, now I'm doing part 2 and ADC analog-to-digital converter. So here is a potential meter, which is going to be connected to a 270 resistor and then connected to ADC channel on the MK20, which is actually channel 14. And this resistor is used to limit the current flowing into this channel only. And now let us look at the code. So inside the code we have initialize ADC and do ADC conversion. Inside initialize ADC, before that, inside the main function, we need this clock initialize, and then after that we need to enable sim SCGC6 to ADC 0, and then after that, starting it up, and then we will start by initializing ADC, where we will do all these settings, CFG1, set it to normal power configuration, clock divide ratio 1, short sample time, single ended 10-bit conversion, which is ADC CFG mod 2 bus clock, and then after that for the rest of settings, DSSA asynchronous clock, normal conversion, default longest time, and then from SC2 we will enable software trigger, and then for SC3 we will do start calibration, which is CAL mask, one conversion only, hardware average, and we were using 32 samples average, and then while ADC SC1 we check the Coco mask, so see if calibration is actually completed or conversion is completed, and then from ADC CALF, which is calibration fail flag, we'll check whether the calibration is successful or not. After that, after initialization, we will do conversion inside this infinite loop. So for do conversion, we will have we will do the things for ADC0 SC1A, which is we set it as single-ended conversion, and then we select channel 14, and then after that we will check whether the conversion is completed, and then we will get the raw data from ADC0 RA, and then after that we will, because the system does not support floating point calculations, that's why we will use our own calculations to determine the floating point voltage. So from digit 1, we will do this calculation to get the first digit, and then second digit, the first decimal, and then the second decimal like this, and then we'll print it out from the ADC channel. Now let's look at our board. The board is just here is a potentiometer here. So the board is connected to the potentiometer, and then now let's look at our putty, which will actually print out the value of the voltage. So let's start over again. You can see that starting up, initializing ADC, and then it will print out the value of the voltage. And then the 6 here is actually I'm printing out the raw data value. And then now by slowly turning the potentiometer, you can see that the voltage is actually slowly increasing, and then you can see the raw data value is also increasing, and then I will keep on increasing it until finally it's 3.3 volts. So the raw data should be 1023 for 3.3 volts because I'm using a 10-bit conversion. Okay, now for part 2, section 2. It's actually the same thing, same settings, but no calculation is required. We will straight away get the raw data inside the main function. It's the same, but inside do ADC conversion, we straight away get the raw data. And then another difference is from here, ADC SC1A, we will be selecting channel 19, which is actually connected to the light sensor. So now let's look at the board for a bit. The board now is actually using only the light sensor. So let's start all over again. We'll reset it, and then now here. And then I will be changing the intensity by using this flashlight here. And then let's look at the values. So now I'm not using any flashlight. It's around 900 plus for the light sensor. And then I will be using the flashlight, getting closer to it, and you can see that the value is actually, it's not so constant, but let's change a bit on the view. Okay, now we are getting a constant of 50 plus, which is a very small value, which is actually when it's on very high light intensity. And then now I will be slowly removing it, moving the flashlight further and further away, and you will be seeing that the values are increasing. And now it's back to 900 plus, around that. Sorry, I changed a bit to show the ADC channel 19 is this value. And then as the light intensity is high, we'll be getting a small value. And as the light intensity slowly decreases, we'll be getting a bigger and bigger value. So let's see again. Now from big value, as I slowly approach the light source to the light sensor, you can see that the value is decreasing until a rather low amount now. Okay, that concludes part 2, section 2.
So right now we are doing the part 3, application and integration. By combining the part 1 coding and part 2 section 2 coding, we are able to came up with this coding to do the part 3. And the only part that we did add something to the code, which is this part, which is getting the raw input, and after getting the raw input, we'll compare the raw input with the range. And by comparing the raw input with the range, the LED will light up, which according to the range which is set. And as the light intensity increases, the LED will light up from the first one to the last one. Sorry. And from the board, we can see that when I shine the light to the
move a bit.
when I shine the light to the light dependent light sensor, and the intensity increases, as well as the LED light up accordingly one by one.
难看到。
Yes, the LED light up till the end as the light intensity reaches its maximum.
慢慢也就好。1, 2, 3, 4, 5, 6. Yes.
And that's all for the lab project.